Namaste and a very, very good morning to all of you. I welcome you to my channel, The Outlier. Today's topic will be about data science in post-COVID digital economy. This is going to be a very, very exciting session because we are going to uncover the different facets of data science in the post-COVID digital economy. I request you to subscribe to my channel, The Outlier. Without wasting too much time, let me go straight to today's agenda. I will be mainly focusing on 5 points. The first one is introduction. This will be a brief introduction about myself. The second one would be the challenges. When I say challenges, I'm referring to the different challenges that a newcomer would face in the world of data science. What are the different obstacles? What are the different hurdles? What are the different roadblocks that a person would encounter in this particular field? We are going to look at this in some depth. The third point that I would be talking about would be data evolution. It's very, very important to understand the different types of data, the different formats of data, and why is data science gaining so much of momentum and ground in today's day and age. This is the third point of my talk. The fourth point that I would be discussing would be the history of data science. It's important to get a perspective about the history of data science because unless you know where you have come from, it will be very, very difficult to appreciate where we are going. The final point of the discussion would be about applications of data science. So these are the 5 different points that I'll be talking about: introduction, challenges, data evolution, history of data science, and applications of data science. To begin with my own introduction, since this is the first video that I'm making, I'd like to introduce myself. I am an alumni of Bangalore University. I have done my bachelor's and then I moved on to do my master's in statistics from Bangalore University. That was way back more than 15 years ago. Now, uh, in uh, in my master's, I had different subjects. I had close to 25 different subjects, from design of experiments to regression to stochastic process and real analysis and such things. It gave me a lot of idea about the theoretical background about statistics. However, the course was silent, quite silent on the practical applications of data science. Those days, we never used to call data science as data science. We used to call it as predictive analytics. Now, this is in my bachelor's and my master's. I also got exposed to different technologies like Minitab, MATLAB, SPSS, and such things. But as I said, practical application of data science was somehow missing from the course. Now, after getting my master's in statistics, I took up a job in SPSS. Now, in SPSS, I got a lot of exposure in the field of statistics. As you all know, SPSS is a very, very popular and a very versatile tool. It is used in different verticals. It is used by different domain experts. Once upon a time, SPSS stood for Statistical Package for Social Sciences. Then somehow things went on developing, and I moved from strength to strength. I also acquired a lot of knowledge in R and Python. Today, I can confidently say that I know approximately 25 different technologies. Three of them are on your screen. Besides this, I'm also aware of Alteryx, Orange, and I also love to use a lot of other tools, particularly Minitab, MATLAB, so on and so forth. Now, some of my areas of expertise involve statistics, machine learning, and artificial intelligence. These are some of the areas of my expertise. And during the future, I'm going to make a lot of videos about these three different areas. Now, I can say that I have a certification. I'm an IBM certified professional. I've also done my Kaizen certification that was around 8 years back, wherein I was working for an insurance company. I'm also into EDT, which is enterprise design thinking. This is an idea which is very, very popular, especially in today's day and age. Now, some of the clients that I've interacted with in at various stages of my career, some of these are very, very prestigious clients, and they give me goosebumps even today. One of the most prestigious clients that I have had an opportunity to interact with was the Planning Commission of India. That was way back in 2010. Then I also had an opportunity to present a POC, proof of concept, for bureaucrats in Ministry of Commerce. Thirdly, I also had an opportunity to interact with IIM Bangalore. That was for a very, very brief period. These were some of the domestic clients that I've interacted with. As far as international clients are concerned, I've had interaction with QNRF, which is Qatar National Research Foundation, Dubai Customs, and several others. So this is a very, very high level, 10,000 feet perspective about who I am and what I do. I'll just quickly move on to the next stage. Challenges. Now, when I say challenges, these are the challenges that a newcomer in the field of data science would encounter. I am sure that most of you would have encountered these challenges. I'll just list these challenges one by one, and we'll also see some of these strategies at a very, very high level as to how you can sort of solve these challenges. As I said, I'm going to make a lot of videos in future wherein we are going to sort of create a bottoms up approach so that we can take a few toy problems and solve these toy problems, which will give you a rich perspective into each of these challenges that newcomers in the field of data science would face. The very first challenge that I feel that people face is statistics itself. Now, if you are somebody who is passionate about numbers, if you're somebody who's passionate about calculations and such things, it's fine. But what happens to a person who does not have a statistics background? What happens when numbers frighten you? That's a bit of a challenge, and I've seen quite a few people who do not have a background in statistics, but somehow because of the profession, because of the chosen profession, or because of the pressure of the times that we are living in, they are somehow forced to use statistics in such things. Now, to just narrate a simple incident, around 15 years back, I was in Mangalore and I met a very learned English professor. Now, he was telling me about some of the challenges and how he and his guide were trying to solve certain challenges in the social field. They wanted to basically find out whether the social benefits that the government offers has percolated to the last man on the street. Now, his guide supposedly had asked him to use factor analysis, and he was literally in deep strife because he said that he is expected to do a lot of these statistical tests, hypothesis testing, and somebody is asking him to do KMO test, Kaiser-Meyer Olkin test, and what is factor analysis, what is MLE, maximum likelihood estimation. He's supposed to interpret the results and give it back to the guide. You can imagine for a person, I mean, he's told me that it's almost like 25 years ago that he has had any exposure to the field of mathematics. You can imagine for somebody who has touched upon statistics and mathematics when he was doing his 10th standard, for him to suddenly jump and take a big, big leap and to talk about factor analysis and the nuances of statistics, it would be quite intimidating and quite frightening, to say the least. Now, this particular course, these videos which I'm talking about are mainly designed to that particular audience, that particular segment, which may not be which may not be uh, well versed with numbers, It depends on when people are intimidated with numbers or frightened with numbers, when people do not have a background in mathematics. How do you still take the principles of statistics and apply them so that you can solve your practical problems? Not all of us want to spend time learning what is Hotling's t-square or what is chi-square test, but we want to look at the application part of statistics. So one thing which I would like to assure my audience is that mostly I'll be talking about the application of statistics and not statistics per se. So this is one of the biggest obstacles, statistics. Add to this, another big challenge is programming. Now, I know that there are a lot of people who speak highly about R, Python, and C++ and such things. But again, there is a segment of there is a segment of audience who might not appreciate too much of programming, as you might not have a background in programming. Not all of us want to spend a couple of hours finding out where there is a comma that is missing, or where there is a hyphen that is missing, or where there is a small spelling mistake and such things. So when you do not have a background in programming, how do you sort of do data science? That's another big question mark. We will look at some of these strategies as to how you can sort of minimize the use of programming. There are a lot of beautiful softwares which are menu driven softwares. I will try my best to impress upon you how you can use some of these menu driven softwares to derive worth and value out of the data. Now, as if statistics and programming were not complicated enough, the third big challenge, the third big elephant in the room would be the interpretation of the output, right? Many times what we see is people purchase very expensive softwares which is worth lakhs together, and you push in some data into the software, and the software quickly sort of does some processing and gives you the output. When you get the output, not many people are very sure about what is the output telling them. Somewhere you're getting a R square, you're getting an adjusted R square, you may be getting stationary R square, you may be getting Nagelkerk R square, you may see a lot of intimidating output, what is p value, what is standard error, what is odds ratio, and such things. And if you do not have a background in the field of statistics, again, this is quite frightening to say the least. So this is the third challenge that I have noticed uh, based on my talks with different people and different people and different experts from different domains. The fourth point here would be about interview questions. Now, this is very critical because I see a lot of graduates who are very good with programming, and sometimes they're also good with which technique to apply, what is supervised learning, what is unsupervised learning. They have a feel of it, but how do you sort of challenge questions in the interview? They are completely blank on it. So I will be making a lot of videos which will sort of boost your confidence, which will sort of strengthen your confidence, and will help you face the interview very confidently. And the fifth part is technology. Now, what I've noticed in my field is that every Tom, Dick, and Harry, every Jack, Jill, and Mary who comes up with something new creates a buzzword. And these buzzwords sometimes become, again, quite frightening to say the least, as to what do you make of these things? You know, somebody's talking about neural networks, somebody's talking about natural language processing, somebody wants you to become an expert at machine learning, somebody feels that natural language processing and such things pay you better, so therefore you have to learn a lot of regular expressions and such things. Now, where do all these terminologies fit in, right? Now, it feels almost as if you are slamming against a wall of buzzwords. So technology sometimes, when we speak about open source technology, you can just broadly divide into two parts: open source technology and closed source technology. You have infinite number of technologies that are in the market. Some of these technologies get outdated, which means that you're forced to learn new technologies. What do you learn, what do you not learn, how much to prioritize, which one do you prioritize? These are all certain challenges that I have personally felt that a lot of newcomers, graduates face. So, to just summarize this at a very, very high level, you may be a housewife who might have done her MBA 20, 25 years back. You may be a purchase manager who wants to learn about data science. You may be a professional with 6 years of IT experience and you want to sort of shift your job, shift from one job to another. You may be a college kid. You may be a graduate who is looking for his first job. So, regardless of what avenue, which avenue you're from, I'm sure that the discussions that we are going to have in the subsequent days will benefit you richly. So, I request you to stick with this presentation so that I can sort of demystify some of these concepts and ideas at a very, very high level. Now, this is very, very important. I'm just moving on to the next stage of my presentation, which I'm calling as the story of data. Now, this is a very, very important thing to understand about the story of data. Now, this segment is important because I want to impress upon my audience the different kinds of data, the different challenges that data present, and how we can resolve each of these challenges effectively. That is the objective of the next 4 or 5 slides that I'm going to show you. Okay, let me just pause for a moment and ask a very, very simple question. Do you recognize the picture in front of you? Do you recognize the man on your screen? Yes, I can almost hear some of you say that it is Nandan Nilekani. Yes, you're absolutely right. He's Nandan Nilekani. He's a bureaucrat, politician, entrepreneur. He is the co-founder of Infosys, a very, very knowledgeable man. He was invited sometime back, around 4 or 5 years back, to IIT Madras, wherein he was present for the convocation ceremony. And during his talk, while he was addressing a bunch of young students, he used an expression, a very, very curious expression. He said that data is the new oil. He was talking about a variety of issues. He used this expression, data is the new oil. And coming from such a important person, the media sort of picked up this expression and it hyped it up in a big, big way. So the following day, you had a lot of newspapers report that Nandan Nilekani says that data is the new oil. And frankly speaking, I myself was not very clear as to why is he comparing data with oil of all things. So I just had this question for some time. I tried my best to inquire from a lot of people. Nothing made much sense to me, right? I'm sure that you too have this question in front of you. I'll just sort of explain this. Again, you see another picture in front of you. A man who needs no introduction, Mukesh Ambani. He's a billionaire, the richest man in Asia, MD, chairman, and the largest shareholder of Reliance Industries Limited. Now, he was speaking to a bunch of entrepreneurs at the FICCI, wherein he took this expression to a whole new level, where he said, "Data is the new oil, and intelligent data is the new petrol." I repeat, he said that data is the new oil, and intelligent data is the new petrol. Very, very interesting. This has become more like a catchphrase ever since he used it. Now, again, it sort of bewildered me. It sort of baffled me as to one more important person speaking about data and comparing it with oil. A journalist basically asked him as to why, of all the things, data is getting compared with oil. And he had a very, very curious explanation. And I want to sort of draw your attention to what he said. To give you a larger perspective, what Mukesh Ambani said was Industrial Revolution 1.0, right? You have to go back to 4 centuries, 350, 360 years back to understand as to where this phrase is coming from. In the 300 400 years back, when we had Industrial Revolution 1.0, that was mainly triggered by the discovery of coal and steam. When people found out coal and steam, that led to the invention of steam engine. What this achieved for us was mechanization of production. To put it in simple language, from farms we moved to factories, and from hands we moved to machines. So as you all know, machines basically don't fall sick, fewer error rates because of machines, more accuracy. Machines can work tirelessly. So this sort of resulted in a big paradigm shift as far as human thinking is concerned, that is Industrial Revolution 1.0. Almost 100 years later, what we saw was Industrial Revolution 2.0. Industrial Revolution 1.0 led to Industrial Revolution 2.0. That was largely because of electrical power and oil. Now, what this did was that it led to mass production and distribution. And a lot of people believe even today that Industrial Revolution 2.0 was the most important out of all the industrial revolutions. Now, this was a phase wherein we invented automobiles and planes, and transportation logistics got a huge fillip. It got a huge shot in the arm, and the items, the articles which people would produce because of machines were basically taken from the place of production to far off places, and therefore transportation and such things played a vital role in Industrial Revolution 2.0. Now, to cut a long story short, let's quickly move on to the next 50, 60 years later, wherein we had Industrial Revolution 3.0. That was largely because of electronics, automation, and siloist software. Now, this gave us the tools for efficiency and productivity. This gave us the tools for efficiency and productivity. Now, that is as far as Industrial Revolution 3.0. Now, the industry is waiting desperately for the next big revolution, which people call as Industrial Revolution 4.0. A lot of people believe that that is because that is going to happen due to the convergence of physical, digital, and biological sciences. In Industrial Revolution 4.0, uh, please note connectivity and data. These are two elements which are going to play a big role. And this will sort of give us the opportunity to solve very big problems in a very short time. So data is going to be at the heart of Industrial Revolution 4.0, which is going to sort of power the economy as far as this century and the coming centuries are concerned. Since data is a natural resource, and I must say that India, because of its sheer population, we are a nation of 1.35 billion people. There are a lot of people to use and generate data. So, in that sense of the word, India is positioned very well to take advantage of Industrial Revolution 4.0. So this is the reason as to why you have so many big wigs say that data is the new oil and intelligent data is the new petrol. Just want to add another point here. There's a lot of similarity between data and oil. Now, if you ask me personally, what is the benefit of crude oil? Crude oil is useful, but it does not have real value. But once you take crude oil in and you are able to process crude oil, you're able to refine crude oil, you get very valuable products like Vaseline, grease, diesel, petrol, kerosene. Now, these are the byproducts of processing. Now, once you get Vaseline, petrol, and diesel, I don't have to explain to you what is the abundant benefit of each of these products. So, just as crude oil in its raw form is not beneficial, the same way data in its raw form is not very beneficial. So, what do we do with raw data? The answer is very simple: we process it. Why should we process it? Because human mind is not very efficient in processing large sums of data, and therefore we need to take the benefit of technology to process data. And once we are able to process data, we get very rich insights, and these insights can be sort of then taken to the end user. It can then be taken to the business manager or the marketing manager, and we can use this to shape up our future course of action. So this is a very high level perspective that I intended to give about why is there so much of excitement about data science. We have a lot of data, and we have not utilized data in its fullest. We have a lot of opportunities to use data, we are going to see some of the strategies, some of the ways, some of the tools in which we can sort of derive worth and value out of the data. Let me make a move on to the next stage of my presentation, which I am calling as data explosion. Very important, very important segment of my presentation, because this is going to give you a perspective about what exactly do I mean by data, right? In case you are not in the know of what is data, let me just tell you, data is nothing but facts and figures. It's just a table which carries facts and figures. As we have discussed, data by itself is useful but not very valuable. And in this segment, I'm just going to draw your attention to uh, why and how have we come to this stage wherein data has such a big role in our decision making, in our thought process. In my own opinion, there are four big reasons, four very big and very powerful reasons which have sort of led to the explosion in the world of data. You're going to see a few pictures. Which I'm going to which I'm going to use to impress upon my audience as to the role that evolution of technology has played in triggering explosion of data. So let me show you the first picture, which is something which everybody has used, a landline phone. In the earlier days, people used to use landline phone. Perhaps if you ask your parents or your grandparents, they would be able to relate to the good old days of the 60s and the 70s and much of the 80s, when people would find it, people would use the landline phone to make a phone call. Today, what do we see? In today's day and age, almost everybody uses a smartphone, right? You can just see as to how technology has evolved over a period of time. Now, sometime back, 15, 20 years back, we used to use bulky desktops, right? And we used to use a lot of floppy disks and CDs and such things. Very difficult to sort of store too much of data. Processing speed was very low. These were some of the challenges that we faced some time back. What do we have today? In today's generation, we sort of use a lot of hard disks. A lot of people sort of also try to store the data in cloud. Going forward, you see a picture of ambassador car, and you contrast it with what we have today. That is, we have smart car. So I'm trying to display six different pictures. The first three pictures at the top reflect the world as it was 40, 50 years back, right? Slow paced, very slow paced, very limited data, and hence limited scope for analysis. In the bottom half of the slide, you see the world as it is today. Now, let's just try to understand this in a slightly different perspective. Now, as I'm showing you, in today's day and age, we have Android, we have iOS, and we have smartphone. Maybe you do not realize, but every click that you make, every click that you do on your smartphone triggers and generates data. When you send a text message to your friend, when you send a picture to your friend, when you share a video on your WhatsApp or on your Messenger app, what exactly is happening? What is happening is basically you are generating data. Maybe you do not realize it. Maybe you do not. Maybe you do not. Know about this, but knowingly or unknowingly, consciously or unconsciously, everybody is acting like a factory of data, because almost everybody uses WhatsApp in today's day and age. We all use different messenger apps, we send mails, and COVID has only amplified the usage of many of these applications. And therefore, because of the fact that we use smartphones, tremendous levels of data is generated. This is the first example that I had. Let me take you to the picture to the right side, wherein you see a smart car. Now, what's a smart car? It's basically a driverless car. Now, a smart car is something which is very, very interesting. It's a device wherein you have sensors which are fitted, and these sensors record the most minute details of the surrounding environment. It records details like what is the size of the obstacle. It records details like what is the distance of the obstacle from the car, and it records several other details. Can you imagine if a smart car drives for 1 kilometer, how much of images it would have? It would have accumulated massive levels of image data. Now, this is where it gets very, very interesting. Where in the good old days, drawing you would have data in the form of a spreadsheet. You do a simple frequency chart or a pivot table, or maybe you try to summarize the data in one or the other fashion. But in today's day and age, when we speak about data, I'm not just referring to data which is in the form of tables. Now, I was just talking about WhatsApp images. I was just talking about images that are present, that are emanating from the usage of driverless cars. You have data which is in the form of images. You sometimes can get data from different sources, which could be in the form of videos. Just think of your CCTV cameras and such things. Just think of customer reviews and such things that you sort of give. You have data which is in the form of text. Now, this is not an easy game anymore, because the data has changed its complexion. No longer are we talking about just structured data. We are also talking about what is called as unstructured data. That is data in the form of audio, video, images, so on and so forth. We will explore this in some depth in the coming slides. But the purpose of showing this slide to you was to tell you that technology is one of the primary reason as to why we have abundant data, and also we have data which is of different form, right? Not one single form which is of the nature of structured. We have structured data, unstructured data, semi-structured data, quasi-structured data. We have different formats of data. So different we need different strategies to deal with this kind of data, which is what we're going to explore in the subsequent slides. This is the first reason, evolution of technology. Let me make a move on to the second big reason, IoT. I'm sure that you all have heard of IoT. Now, what is IoT? IoT stands for Internet of Things. Now, what does the IoT do? It basically connects your physical devices and makes your devices very, very smart. Now, in the last slide, we were talking about smart car. You might have heard of smart AC. You might have heard of smart city. You might have heard of a lot of other things like smart TV. Let me just give you another example of smart AC. Now, what does a smart AC do? Now, what a smart AC does is it monitors your body temperature through sensors and other instruments, perhaps which you may not even be aware that it is monitoring your body temperature and such things. It also, with the help of internet, gathers outside data about what is the temperature, what is the humidity level, what is the wind speed, so on and so forth. And by comparing these two things, it's able to regulate the room temperature automatically. Now, this is the beauty of a smart, this is the beauty behind a smart AC, that it's able to automatically regulate the inside room temperature through a variety of metrics that it is going to collate. Now, if a smart AC operates for 24 hours, just imagine the humongous levels of data that you would have at your disposal. So this is the reason as to why we say IoT is the second big reason as to why we have an explosion in the world of data. I was just reading somewhere that by 2020, we are expecting around 50 billion devices to be connected. 50 billion devices is really not a small number, it's a humongous number. So you can imagine the kind of role that IoT is playing in generating data. So this is the second big reason. Let me just quickly move on to social media. Now, since we are mostly in home, most of us have to continuously send emails back and forth. Now, it's estimated that around there are 20 crore, 40 lakh that emails that are being sent. Approximately 41 lakh 66,000 plus pictures are basically liked. You have around 2 lakh photos and 2 lakh photos which are being shared on Facebook. Let me just show you the third item here, which is basically Twitter. We have around 3 lakh 47,000 plus tweets that are being sent out. Instagram, 17 lakh odd Instagram pictures. We have around 1.5 billion messages that are being sent across in WhatsApp, and we have 1.5 billion active monthly users. Uh, and finally, YouTube, 300 hours of video uploaded. These numbers are really, really frightening. In my opinion, social media is one of the biggest out of the four reasons that we are going to talk about. One of the biggest reason as to why we have an explosion in the world of data is because of social media. Now, every picture that you share, that you react to in your that you react in your favorite social media site, that is basically getting recorded and it is getting stored somewhere. Uh, Now, many of these social media sites have very, very rich detail, like your personal details. They have details about your age, your gender, your marital status, where do you live, what do you eat, what was your birthday, what's your date of birth. And also, every picture that you like or react is generating data. Now, in Facebook, when you go around liking or disliking data, you are generating data. Maybe you're not conscious of it, but take my word for it, you are contributing immensely to the generation of data. Now, these days, you see a lot of people share videos on Facebook and such things. When people share videos and such things, what's happening? They are generating data. Now, there could be millions of other ways in which data is getting generated. Possibly, it's not practically possible for me to list out all these reasons. These are the three reasons, and there could be other factors. I'll just give you a high level perspective. You have other factors like retail, government, insurance, banking and finance, media and entertainment, healthcare, science and technology, pandemic, transportation, e-commerce, education, gaming industry. I've just, at a very, very high level, listed out 12 reasons as to why we have an explosion in the world of data. Now, it's a bit difficult for me to get down to the brass tacks and explain in detail, but I'll just pick up one or two areas. One of my favorite areas is e-commerce. Now, when we speak about e-commerce websites, there are umpteen number of e-commerce websites, and because of COVID, a lot of people are actually scared to go online. People are scared to go offline. So what do? We mostly purchase online. Who has not used Flipkart? Who has not used eBay? Who has not used Snapdeals or Jabong or ShopClues or Amazon or Quikar or Alibaba or Tencent? These days, by and large, most of us use this. Now, when we go to Flipkart, and let's say I'm a book reader and I love to read Agatha Christie's books. One of my favorite books may be Sitterford Mystery, or I may pick up another book, Dead Man's Folly. Right, these are some of my favorite books. Right, next time I go to Flipkart, it what it does is basically it automatically starts making recommendations saying that people who read Agatha Christie's books are also likely to read Sidney Shelton's book, or maybe Dan Brown's book. Right, the question is, how is it able to make a recommendation? The answer is very, very simple. Every time you go there and click items, every time you go there and click items which is to be added to the cart, or which is going to be added to the cart, what Amazon or what Flipkart does is basically they record the purchase history, the past purchase behavior or your digital footprints. And based on these recorded digital footprints, next time you visit any of these e-com sites, it is able to compare your behavior with others' behavior, and it is going to make a recommendation. right? You go to YouTube, and maybe if you're a big fan of Kishore Kumar and you love to read Kishore Kumar, you love to hear Kishore Kumar songs. Next time you sort of next time you reopen the session, it quickly sort of identifies certain songs of maybe Muhammad Rafi or other popular singers and makes a recommendation. So what is happening here is that e-commerce and such websites are basically capturing a lot of data about consumers which we are not even aware of, right? So these are some of the reasons as to why we see an explosion in the world of data. So we cannot complain in today's day and age that we have shortage of data. No, really, we do not have shortage of data. We have abundance of data, we have a flood of data, we have a barrage of data coming our way. The question is, are we prepared to analyze the data? And if we want to analyze the data, how do we analyze the data? Do we have, even before analyzing the data, do we have sufficient wherewithal to even store the data, retrieve the data, report our findings and such things? This is a different ball game at all. But the purpose of these 4 slides was to impress upon my audience that we have abundant data, not limited data. One final segment which speaks about not just the volume of data but the speed of data. Now, in the good old days, we had the mainframe computers, very, very bulky systems, very little data because very few people would use these systems. The mainframe systems moved to the client server architecture. From there, what we saw was uh, the time for web application had arrived and the internet boomed. The masses basically took a liking to the internet, and a lot of people started using many of these web applications and such things, and the usage of web application proliferated in a big way amongst the masses. Now soon you had a situation wherein people were using these web applications not just from their computers but also from their mobile phones, right? And this basically led to a tsunami of data. Now this is where we are. I do not know what is going to come after this, so I've just put a question mark here to leave you with a food for thought, right? I'm just showing you some of these statistics. Please don't be terrified by this. Just very important to note that the statistics which I'm showing to you at the right side, this is not statistics at a per day level or at a monthly level. Don't be shocked, but this is data which we are seeing at a per second level. Each second we have 1 lakh plus tweets. Each second we have approximately 7 lakh Facebook status updates. We have around 1 crore 10 lakh instant messages. We have approximately 7 lakh Google searches. We have 10 crore 80 lakh emails, and we have 1820 terabytes of data created, and we have 217 new mobile users coming into the system each second. So can you imagine what is the kind of data, the scale, the level of data is something else, which is, we have never seen the history of mankind, this kind of data that is being generated, that is lying somewhere. It is up to us that we choose to either ignore it or we take some action to sort of change our life, our lifestyle, and to change the destiny of our country. Now, as I said, the last 5 slides in this segment was about data explosion, wherein I was just trying to explain at a very high level the kind of data that is sitting idle. Most of this data, mind you, though I'm talking about data, it is not that we are utilizing all of this data. We have to find a way of utilizing all of this data, and this video and the subsequent videos basically will help you with various tricks, various tips as to how we can sort of harness this data. At this stage, I would request you to subscribe to my video in case you have not done it. All right. Now moving on to the next stage, the next stage is about data science. I've spoken about data. Now we are going to speak about data science. Now, this is a popular phrase that you'll always hear when we speak about data science and such things. What is data science? Very, very difficult to just address it in one sentence. We always say it's a multidisciplinary approach. Now, what is this multidisciplinary approach? Let me just illustrate it with the help of a simple diagram. Now, one of the critical one of the critical elements, one of the critical disciplines which make up data science is statistics. Now, as you all know, statistics is not a new subject. Statistics has been around for more than 250, 270 years. It's a popular subject. A lot of people use it. So regardless of what is your background may be genetics, your background may be biotechnology, your background may be chemistry, chemical engineering. You may be a student who has done physics. You will be using a bit of statistics. And statistics forms a very, very important and a critical role when you analyze data. Now, it could be just summarizing the data. When I say summarizing the data, let me just give you an example. I can just make a very, very factual statement, very simple and a factual statement by saying last week we had around 2,000 cases in Karnataka. I'm just giving a rough number. When I say 2,000 cases, what have I done? I've just summarized the data. I can also use statistics to make a forecast and say, in the coming week, I'm expecting around 5,000 cases. So whether you're trying to summarize the data or whether you're trying to forecast, statistics forms the backbone of data science, right? So to just give you a hint or a clue as to whether people are talking about statistics, watch out for these words. When you're talking to a person, if a person uses words like chi-square test, parametric test, non-parametric test, normality, time series analysis, regression, logistic regression, probit analysis. We are in the world of statistics. Please don't be intimidated with any of these techniques at this stage. We will look at each of these techniques in detail as time progresses. So this is the first element of statistics. This is the first element of data science, I beg your pardon. The second element is basically computer science. Now, to operationalize statistics, it is not so easy. You can't do a lot of these statistics. Real-time data analysis cannot be done manually. You can't use pen and paper to analyze your data. You need to use computer. So you have a lot of algorithms. You need technology to some extent. You need technology to a large extent. My apologies, but computer science basically forms the second important piece. It forms the second important factor as far as data science is concerned. So we have statistics and we have different algorithms and such things. We have computer science. The third element that I wish to talk about is technology. Now, technology, as I said, we can't process large data using pen and paper. We also cannot process it using our mind. Unless you have an Albert Einstein like brain, it becomes extremely difficult to process large sums of data. So we use technology. We have different types of technology. You might have heard of Hadoop, you might have heard of Spark, you might have heard of different tools here. Don't be intimidated with some of these things. We will look at each of these items in depth. So statistics, computer science, you need technology. The fourth critical element that we use in the field of data science would be visualization. Now, there's a famous saying in English that a picture speaks 1,000 words, right? Now, what you can convey through lengthy tables, what you are trying to convey to the end user by using complicated metrics like unstandardized coefficients, or let's say standardized coefficients and such things. Or sometimes the end user may be intimidated when he looks at p-value, when he looks at something like your r square or adjusted r square and such things. The question is there a better way? Is there a simpler way? Is there an easier way of summarizing this so that the last man on the street can understand what we are talking about. So we have a lot of visualization techniques and such things. We have a lot of graphs, charts, 2D charts, 3D charts, and such things which help us summarize the results of our analysis, so that it becomes very, very easy for the last man on the street to consume the output of data science. So this is the fourth critical element. The fifth and the final element that we use in the field of data science is operation research and mathematics. All right, operation research. You might recall, some of you who have a background in operation research, or who might have done your BBM. You might recall techniques like simplex method, Charles Bigham method. You might recall techniques like PERT and CPM and such things. You don't have to recall those very, very complicated formulae and such things, because as I told you, please remember, this is a place wherein the emphasis will be more on the application part, not necessarily on writing the formula and such things. So even if you are not good with the formula, please don't worry, please don't be intimidated with this. Even if you're not good with programming and such things, don't worry too much about this. We will find out ways in which we can just simplify the subject, break it down to the nuts and bolts, and we can still take the benefit of data science to solve problems. So to just summarize, data science is a multidisciplinary approach. It comprises of statistics, computer science, technology, visualization, and or slash mathematics. Now, please remember these high level at a very high level. You can just remember this discipline, because the next slide will be slightly frightening, and I know that a lot of people might start cursing me, but if you sort of just keep these five elements in mind, the next slide will be uh, less frightening. Uh, okay. So this is a slide, and whenever I show this slide, people usually sort of get intimidated. Nothing to worry. All that I'm trying to do is say to my audience, all that I'm trying to do is convey to my audience that there are five different disciplines, and each of these five lines correspond to one discipline. For example, you can see the line right at the top that corresponds to computer science. Second one is technology. Third one is visualization. Fourth one is mathematics. Fifth one is statistics. And right at the bottom, you can see pre 1800s all the way up to 2010. How have each of these disciplines evolved? Right, so for the last 200 250 years, you have various scientists, we have various researchers, we have various mathematicians work continuously day in and day out, and they have given us tools, they have given us equipment, they have given us ideas about each of these disciplines, which have made data science possible. Now, I always like to use a simple analogy. Just think of five different streams of water. Each of these streams of water start their journey at a different place, but though they start at their journey at a different place, there is a place wherein there is a meeting ground of each of these five different streams, and when they meet, they become a river. Right, the same way here, you have different disciplines. Each of these different disciplines have undergone many changes, modifications, and such things. And today, each of these sciences, computer science, data technology, visualization, mathematics, statistics, have evolved, and they have converged to a point. And this point is what we are calling as data science. So data science uses each of these disciplines. Don't worry about the nitty-gritties of this particular slide, but just get a high-level perspective about what data science is all about. Now, since we have spoken about data science, now from a 10,000 feet perspective, let me just bring you to a 10 feet perspective, because in this segment, I'm just going to talk about the different types of data. Now, I believe that if you can understand the different types of data, and if you can sort of be very, very comfortable with the different types of data, analysis, what kind of analysis that needs to be done, what kind of analysis and strategies that you need to propose, that becomes a lot simpler, that becomes a lot easier, right? So let's just look at this particular slide. You can see two different types here, right? I've called this as type 1 and type 2. Now these are some of the phrases that I use. These are some of the ideas that I used in the world of research, in the world of statistics. And if you can get comfortable with these terminologies, there is nothing like it. Please use this slide more as a glossary, because if you can use this slide more as a glossary, it will definitely benefit you. Now, there are two types of studies. One is what we call as cross-sectional study, and the second is what we call as time series analysis. So we have cross-sectional study, and we also have what is called as time series analysis. Now, let me just come to a cross-sectional study. Now, let's say I'm a professor and I enter a classroom and I take the attendance of 60 students, right? Who is present, who is not present? I put my signature on the register and I go. What kind of data is this? This is an example of cross-sectional study. It is not an example of time series analysis because the data is not varying with respect to time, right? It is data at that point of time, more or less, right? So cross-sectional study is usually contrasted, is usually compared with time series data. Now, when we speak about time series data, as the name itself suggests, time series, it is time is the operative word here. If you can just focus on time, I think it is self-explanatory. Each row corresponds to a slice of time. It may be daily, it may be daily, or it may be monthly, it may be quarterly, it may be hourly, it may be at the level of second, right? When you have data which is varying with respect to time, that is called as time series analysis. Now, this terminology, if it is not very clear at this stage, don't worry. In the subsequent slides rather, I have got I'm just going to sort of show you what is the difference between cross sectional and time series analysis. Now, the second kind of data based on the source of the data that you would see is what we call as observational data. And observational data is usually compared and contrasted with what is called as experimental data. Now, let me just draw your attention to experimental data. The operative word being experiment. Experiment. Now, let us say you're working for an automobile industry, and there are two types of fuel: fuel X and fuel Y. You do not know whether fuel X is better than fuel Y or not, right? You do not know in terms of mileage and such things. You do not know whether fuel X gives you better mileage or fuel Y gives you better mileage. So what do? You take each of these fuels, and let's say you have three different engines, A, B, C. You put each of these fuels, fuel X and Y, in different vehicles of different engines, and you try to observe what is the mileage that it gives. Let us say in the case of fuel X, it is giving you a mileage of 25, 23, and 26. I'm just roughly giving you certain numbers: 25, 23, and 26. In fuel B, when you look at the mileage, it may give a mileage of 19, 18, and let's say 13, right? You can clearly see that fuel X is generating, it's just giving you higher mileage. How have you come to this conclusion? You have experimented. And by experimenting, you will be able to come to know which of the two fuels is fuel A better than fuel B, or vice versa. Or let me just a lot of these experimental studies are used in pharmaceutical sector. It is used widely in the field of medical research and such things. Let us say, I'm just giving you another example. Let us say you have two different drugs. Both of these drugs are weight reducing drugs. You do not know for sure which of these two drugs is effective in reducing the weights of the patients. So you give drug A to one set of patients, right? And then maybe you can just record the initial weight and the final weight. Then you can administer the second drug on the patients, and you can record the weights of the patients. Now you can just see what is the difference in the initial and the final weight, right? You may come to the conclusion that drug B is better than drug A, or drug A is better than drug uh, A, right? So accordingly, you will be able to conclude. All these things are what we call as experimental study. Now, experimental study is usually compared with what is called as observational study. The operative word being observation, right? You're observing something, right? Here, in the case of experimental study, you're changing something and then you're seeing what is its effect. For example, you changed from fuel A to fuel B and you studied the mileage. In the case of observational study, you're not changing anything. You don't change anything. Let me just give you an example. Let's say you have a traffic police inspector and he's basically interested in studying the traffic, right? So if you're living in Bangalore, you may have 4 or 5 areas. Let's say Southern Circle, you may have Vijayanagar, you may have Rajaji Nagar, you may have Jayanagar and JP Nagar. You are basically observing the traffic between 10 a.m. and 11 a.m. You will record that, okay, there are around 900 vehicles which have passed by. From 11 to 12, how many vehicles have passed by? Let's say 600 vehicles have passed by. From 12 to 1, how many vehicles have passed by? You're observing it and you're recording it. This is also a source of data which is called as observational data. And here, please remember, you are not experimenting, you're just observing and you're just recording the values. So observational and experimental, these are two different types of data. What we have is basically the third type in which data can be classified, right? All these are basically classification of data that we are talking about. You have what is called a structured data and unstructured data. At a very, very high level, if I have to say structured data, the data which is in a proper schema, which can be displayed in the form of rows and columns, can be called as structured data. And I've given a tedious explanation in the beginning of this presentation as to what is unstructured data. You can think of audio, you can think of video, you can think of text. All these things are called as unstructured data. I also, because this is very, very important from the industry perspective, it's also a very, very good interview question as to what is the difference between structured and unstructured data. I have prepared one full slide explaining the differences between structured and unstructured, which I will be covering in the subsequent slide. Next, we have a very, very curious type of classification, which is called as qualitative. And this usually is compared with what is called as quantitative data. Now, when we speak about qualitative data, now this is very, very subjective, right? Now, just think of certain variables like satisfaction or honesty or anxiety level or beauty or happiness, depression, so on and so forth. The question is, can you measure happiness? Right? Can you measure honesty of a person? Those people whom I consider as very honest, you may not consider them as honest, which means there's an element of subjectivity involved in evaluating who is honest and who is dishonest. If you want to evaluate uh, whether a, whether a person is anxious or not very, very easy to do this, right? You don't you there is no measuring instrument as such. You cannot use a beam balance or a weighing machine to evaluate who is honest, who is dishonest, who is depressed, who is not depressed, and such things. So wherever there is element of subjectivity, you call that kind of data as qualitative data. Now, qualitative data is usually compared with what is called as quantitative data, the operative word being quantities. When we speak about quantities, what are we referring to? What we are referring to is basically numbers. Now, this quantitative data is further broken down into two categories. The first category is what is called as discrete data. The second one is what is called as continuous data, discrete and continuous, right? Whenever you see values like 0, 1, 2, and 3, those are values which values which exemplify discrete data. The best example of this would be, let's say, number of people, gender, number of children, right? Nobody says that I've got 2.5 kids. Decimals and such things do not make much sense. Marital status, right? 0 and 1, right? Either a person is married or unmarried. There is nothing like 0.5, right? So no negatives, no decimals, and such things are involved when we speak about discrete data. Now let's look at the other category, other type of quantitative data that is called as continuous data. Now, whenever you hear words like height, width, time, mileage per hour, all these are variables which can be called as continuous data. Now let's just take an example. Now, if you have vehicles which are moving on the road, let's take the simple example of mileage per hour, right? Now, let me just give you a small interval of 60, uh, between 60 and 61. The question is, how many values can you have between 60 and 61? You can have infinite number of values, because 60.10 is a value, 60.01 is also value, 60.000123 is also value, right? So you can have umpteen number of values, you can have infinite number of values within this short interval, right? So this is an example of what is called as continuous data, wherein decimals and such things are allowed. So this is a high level perspective about how we classify the data. Uh, I hope these concepts are making sense, and I hope you're able to understand what I'm saying. In case you have any questions, uh, please write these questions in the comment section. Now, here, since it's very important to understand what is structured and how is it different from unstructured data. I've just put up this slide. Now, from an industry perspective, this becomes very important that you understand what's the difference between structured and unstructured data. Now, very regularly, quite often, we hear of different types of files like audio files, png files, mp3 files, video files, json files, csv files, tsv files. We hear of log files, emails, and many more, right? Where do all these files fit in? Usually, when we speak about data, we classify this as either structured or unstructured, but you can also think of classifying data as semi-structured and quasi-structured. Though I've not put up this piece of information on the slide, you can see a lot of blogs, you can see a lot of articles describing this. At a very high level, structured data is the one wherein there is a proper schema for data. It's usually in the form of a table. Uh, Whereas in the a case of unstructured data, you don't have a proper schema. Your schema is not defined properly, and it becomes very difficult for you to store it in your traditional RDBMS format, relational database management system. Now, what are the examples of structured data? The moment you look at numbers, dates, and strings is an example of structured data. Now, what about unstructured data, audio files, image file, video, word processing files, emails? All these things can be called as unstructured. And a lot of people argue saying that emails is not necessarily unstructured, it should be semi-structured. You can possibly put this in the third type, that is semi-structured as well, right? When you see columns like social security number, bill number, customer name, gender, address, product names, and such things, those are all structured data, right? On the other hand, when you receive data in the form of reports or PDFs, surveillance imagery, and such things, those are all examples of what can be called as unstructured. Now, structured data, it requires very less storage space. When I say less, comparatively, it is less. On the other hand, unstructured data requires more storage space. Now, it's estimated by Gartner that only 20% of the enterprise data is structured. There are so many tools, there are so many techniques for structured data, and a lot of effort is put by the industry in analyzing structured data. But the moot point here is that structured data comprises only of 20%. On the other hand, when you talk about unstructured data comprises of approximately 80% of enterprise data. That's a stunning number. 80% is very high. Now, as I said, there are other ways of classifying as well, which can be called as semi-structured and unstructured data. In the case of semi-structured, the schema is not defined properly. So, an example of semi-structured data would be JSON file, XML file. Sometimes it could be CSV or a TSV or an email can be called as email could be called as semi-structured data. Now, what about unstructured data? It's usually log files, audio, video, and image files could be called as unstructured data. Now, this is a very important segment wherein we have spoken about the types of data and such things. Uh, now, we have spent quite a bit of time understanding about data, the different formats of data, the different kinds of data that we encounter. Now, if we have to formally define what is data science, not a very easy task to define what is data science. Let me show you a picture of a very notable person, right? Do you recognize this picture? He's a Nobel Prize winner in the field of economics. His name is Ronald Coase. Uh, I, uh, I hope I'm pronouncing it properly, Ronald Coase. He said, if you torture the data long enough, it will confess. When we use torture, all that he's trying to say is that if you slice and dice the data set, the data begins telling you a story, right? Now, there are very, very fancy explanations for data. Now, if you ask me personally as a practitioner of data science, what exactly do I mean by data? Right? Just focus on these two words, data and science. The second word, science, is very, very important. Now, you have different subjects which can be called as science. Usually, the moment I say science, people think of physics, chemistry, mathematics, and biology. Fair enough. These are all subjects which can be called as science. Now, in this context, when we say uh, data science involves principles, strategies, ideas which help us collect the data, which help us store the data, which help us retrieve the data. Once we retrieve the data, we have to analyze the data. And after analyzing the data, we have to report our findings to the end user. Sometimes you might want to sort of report your findings to the end user. Sometimes you may want to predict. So both these things are possible. You might want to build a predictive model, or you might want to simply summarize the data. So all these activities which revolve around data, like analyzing the data. Sorry, let me repeat from the scratch. Like collecting the data, storing the data, retrieving the data, analyzing the data, and then reporting the findings to the end user or deployment of the model, whichever the case be. These activities are this entire science, this entire conceptual understanding is what we call as data science. You have a definition of data science. Data science is the process of extracting knowledge and insights from data by scientific methods. Very curiously, 15 or 20 years back, if you ask me personally, nobody used this phrase data science in a big way. Mostly people used to use phrases like predictive analytics. From time to time, people have found the need to change the nomenclature. Could be because one is because we are not working in a very, very controlled environment. Everybody who comes up with a new concept gives his own labels and nomenclature. Secondly, there's also a need to incorporate newer meaning to this particular science, and therefore this science keeps the nomenclature keeps changing. If my memory serves me right, only around 2015 that the usage of the term data science by the masses became popular. Until then, I don't think too many people use this expression data science. Now, this is a very interesting case study. Thank you so much for sticking with me so far. I appreciate your patience. I request you to click on the bell icon. I request you to click on the like button and to subscribe to my videos. This segment, I'll just give you a high level perspective about the different data sets that you may encounter. Uh, Now, one of the first, the idea being, if you sort of see the data set, you will be able to sort of understand what can be done about the data set, right? Let me just show you a classic example of what a retail data set might look like. Now, this is just a hypothetical data set that I'm showing you. A UK-based retail company, Datacom, has more than 800 store outlets selling a variety of consumer products from men's apparel, women's apparel, groceries, and kids wear. Right. This is a brief bit of a background about the data set. Now, this is how a typical retail data set would look like. If you recall, 5 or 10 minutes back, we were speaking about structured data. What is this an example of? This is a classic example of a structured data wherein the data is arranged in the form of rows and columns, and wherein you can display it in the form of table, right? Some of the variables that you might see would be customer ID. What is the store ID that he visits? Is he consuming healthy food or not? Whatever you see, those of you who are used to Excel, you may call them as columns. In the world of statistics, we call them as variables. So when you see customer ID, store ID, health food, store size, organization type, gender, shop for, whether he's buying vegetarian food or not, what's his shopping style, right? You can see here the first person, Raju, he shops bi-weekly and in bulk. The second person does the same. The third person basically shops weekly, and he shops similar items. Now, what about the next variable, coupon usage? Mostly people use a lot of coupons, sometimes from mailing, sometimes from newspapers, sometimes both, or sometimes people use none of them. The last variable is very, very important, amount of money spent, right? You can just consider this as a pivotal variable, because based on the amount of money, a lot of analysis can be done, right? Who's a big spender, who's a small spender, who's an average spender. Now, when you look at this data set, right? Now, as I told you earlier, what is data? Data is just a set of facts and figures. Now, human mind is not very efficient in processing large sums of data. We need technology. But when you put yourself in the shoes of a data scientist, ask yourself, what is the primary goal of a data scientist? If as a data scientist, if you ask me what is my goal, my job is to basically pick up the story from the data set. Every data set is telling you a story. Our job is to pull out that story from the data set, go back and report the insights to the end user, right? That is the goal here. So very, very interesting data set. I think you can do a lot of interesting analysis. I'll show you some of these analysis in the subsequent videos. Uh, but there's a typical data set. This is a typical format of the data set as far as retail is concerned. Now, what you have along with data is also something called as metadata. So what is this metadata? Simply put, metadata is data about data, right? Now, what you see here, it's always a good practice to list down the variable names. You saw all the variable names here, like customer ID, store ID, so on and so forth. Now, I've listed all these variable names. The variable labels are given because it sometimes helps to understand what each of these variables mean if you have a variable label, right? Uh, if you don't have a variable label, it might not be very, very easy to understand what each variable means. For example, let's take the example of a simple variable name, right? When we are talking about name, name is a very simple English word, but the question is, whose name are we talking about? Are we talking about the customer's name? Are we talking about his spouse's name? Are we talking about his father's name or mother's name? Or are you talking about the school name? Or are you talking about the locality name or the country name? It might be very, very difficult. So we use what is called as variable label. Now, you may ask me this question, what's the difference between variable name and variable label? Variable name is just a nomenclature for that column. Variable label is a short description of the variable name. It's a short description. Now, one more thing that you'll always see is what is called as variable level. Level, which is different from label. When I say variable level, just take a look at food type. You have variable categories. One stands for healthy food and two for unhealthy food. Similarly, when you look at the second one, the store size. Here you can see one stands for small, two for medium, and 3 for large. So 1, 2, and 3, these are nothing but variable levels. So variable level and variable label, these are two different things. Now, I've shown you an example of retail case study. Let me just make a move on to the second case study, which is telecommunication. Now, in telecommunication, a lot of interesting analysis can be done. Now, you can see here at a very high level, I'm just showing you some of the variable names like ID, the area, what is the phone number that I have sort of uh, crossed it out. You can see very interesting variables like tenure, age, marital status, address, income, employee, the number of years that he has been employed for, whether he's retired or gender. I've sort of color coded it in green because all these are what we call as demographic details. When we speak about demographic details, this is a phrase that you'll always hear in analytics industry, demographic details. We're referring to variables like age and what's a person's marital status. Is he married? Is he not married? What's his age? So on and so forth. The second set of variables that I've sort of highlighted are like the different services that a person might use, like voice, mail, pager, internet service, caller ID, call waiting service, e-billing service, so on and so forth. This is basically not demographic variables. These are variables which we call as service usage pattern, right? Uh, After this, you have a very interesting variable, customer category, right? There are four types of categories. It need not be always this, but this is use this slide indicatively. Sometimes you can see basic service, people who only buy basic service. Sometimes you can have people who buy additional services and such things. Last but not the least, there is a variable which is called as churn. It's a very interesting variable because in any of the subscription-based business, whether a person churns or not is a very, very important piece of information. When we say yes, it means that he has churned, right? What do I mean by churn? Let's say you're using a mobile phone. Let's say you're using a particular service. You're not happy with that particular service, so what do? You switch from that particular service, you migrate to something else, you make a move on to another service provider. That is what is called as churn behavior. Now, any company would be interested in analyzing what is the churn behavior of the customers. Why? Because the moment you are able to understand what is the profile of churners, and if you come to know that out of 100 customers, these 30 customers are most likely to leave by the end of this month, you can think of retention measures, you can think of reducing their price, or you can think of certain discount offers and such things. Remember, when you lose a customer, it is like losing blood from your body, right? If you have a person who's losing blood continuously, what happens? His body becomes weak. The same way, when you lose a customer one after the other, one after the other, the organization becomes weak. So nobody wants to lose customer. So this is another example of what is called a structured data because it's in the form of rows and columns. And the last variable, churn, is a very, very important metric, and you can construct a lot of analysis. You can do a lot of interesting, you can pull out a lot of interesting insights from this particular data. You can have another perspective about telecom data. I showed you one. Sometimes you can get customer's name, the area code, and you can have other interesting details like what are the number of calls that he makes during the day or during the evening, how many calls that he makes, what are the charges that he incurs, for how many minutes does he speak, right? Same thing for evening, how many calls does he make, uh, for how many minutes does he speak, what are the charges that he incurs, right? Does he make international calls, so on and so forth. This is all about usage behavior. Again, you can sort of historically you can identify whether a person is churner or not churner. Many times what we do is basically you tend to sort of have demographic details in one particular table, you have service usage and such things in another another table, and you have call details. This is popularly called as CDR data, or call detail record. What are the details of the calls that he has made? A lot of murders and such things have been sort of found out by tracing the CDR or the call detail records. right? There was a popular case in Kerala some time back wherein there was an incident of murder, and the police basically uncovered it by looking at the CDR data, right? So here the purpose is to just show you that when you have data, different kinds of data residing in different tables, you might want to merge, you might want to combine, and then arrive at what is called as the base data. The base data is the data which is usually used for analysis. Just a very high level perspective about telecom sector. Now, this is all cross-sectional data that I'm showing you. The last two examples uh, uh, of telecom as well as retail are all examples of cross-sectional. I'll move on to another segment which is called as the government data. I'll just give you a high-level perspective. Very, very interesting. If I could ask you this question, what do you notice which is different from the earlier sets of data, right? You can see here the second variable is very interesting because it says February 2001, March 2001, February, March. You have monthly data here: February, March, April, May, June, July, August, September, October, November, December. Similarly, Jan data you have. And you have WPI. WPI, when I say wholesale price index data of different articles like rice, wheat, barley, pulses, maize, bajra, jowar. All these numbers that you see are the data from Ministry of Commerce website. I just thought of showing you this data set because this is a classic example of what we call as time series analysis. I've explained time series analysis in detail earlier, but you can see the second column that throws a lot of light on what I have in mind. You can see February, March, April, May, so on and so forth. Each row corresponds to a slice of time. And because each row corresponds to a time point, we refer to this data as time series data. So I've shown you an example of cross-sectional data. I've also shown you an example of time series data. Now, text data, very, very interesting. All these three examples may be government, may be retail, may be telecom. They can be called as structured data. Now, let's just look at a very, very curious piece, which is unstructured data. Text data is usually classified as unstructured data. You can see here some file here, which I've sort of pulled out, wherein you can see a person verbally describing his experience, right? You have the tweet, and the second variable is whether that comment is positive comment or negative comment, right? I've underlined a few comments in blue. You can see here there's a person called as Tim Cook, loving my new iPhone 6 from T-Mobile. I'm in love with the iOS. Can't wait for September 9th event. Question is, can we analyze this kind of data? Can we take a mean here or a median here? Obviously, we can't take it. Unstructured data, you have to use different strategy to sort of derive worth and value or this. Can you analyze the data? The answer is definitely yes. There's a resounding yes, which I'd like to say. You can definitely analyze the data, but the tricks that we use to analyze, the strategies that we employ to use unstructured data is very, very different from that of structured data. Look at the last comment, which I've sort of highlighted for you. To all Nintendo fans out there, I may sound crazy when I say this, but Kirby and Rainbow Curse and Canvas Curse should be on iOS. So he has just expressed his opinion. This is a neutral comment. Now, it's not very easy to classify this as a positive or negative. A person has to just imagine, if this data set is given to a person, he has to read each and every comment, and then he has to use his discretion and classify the comment as negative comment, neutral comment, or as a positive comment, right? Not an easy task. Question is, can we feed this into the computer and make the machine learn to classify whether this particular comment is positive comment or negative comment? The moment you feed this into a machine and enable the machine to recognize certain patterns, certain keywords, certain key ideas, and then for the machine to learn these ideas, and for a fresh data, if we are enabling the machine to classify it as positive, negative, or neutral, that is a subject which is called as machine learning, right? Literally, machine learning. You are making the machine learn certain ideas And once the machine learns certain ideas, it is now ready to classify for a fresh data set whether the comment is positive or negative. Now, you may ask me, what is the benefit? It saves a lot of time. Imagine a person manually going through 10,000 or 25,000 comments and classifying it. Compare it with a machine doing it. Machine would do it very, very quickly. It would do it in a jiffy, and therefore it saves a lot of time. You can also expect higher levels of accuracy when a machine does it. Okay, we have covered some ground in terms of different data sets. Now, you may have a few questions in your mind about where do we use this? Can you sort of tell me a few applications of data set? So I've just put up a slide to tell you at a very high level what are the different applications of data set. Now, I'm just showing you four different areas here. One is retail, second one is healthcare, third one is BFSI, and the fourth one is others, right? Now, one very, very exciting and interesting example of retail was in Walmart. As you all know, Walmart is a very, very big retail outlet, is a retail giant in United States of America. Now, this happened sometime in 2010 when Hurricane Sandy hit United States of America, and there was large-scale destruction of property and life there. Right? It's an emergency-like situation. Now, you'll not believe it. The data scientists in Walmart wanted to understand whether there is a difference in the purchase pattern at a time when a pandemic hits. Whenever it's not a pandemic in this case, it's mostly a natural calamity. When a natural calamity hits people, do people change their buying behavior? Do their purchase pattern and such things change? They used a lot of machine learning and such things, and you'll be stunned with the findings that they came up with. They found out that people's purchase pattern, what people buy from Walmart, changed drastically at the time of this particular emergency situation. What data scientists found was that people during an emergency situation bought life jackets, they bought flashlights, and interestingly, they also bought strawberry Pop Tarts. It's unbelievable that the sales of strawberry Pop Tarts increased 7 times as compared to a normal situation. During a normal situation, people would not buy strawberry Pop Tarts as much as they would buy in emergency situation. Now, you may ask me this question: do people want to die buying strawberry Pop Tarts? I don't have any answers, but I know that there are a lot of very interesting algorithms like a priori, generalized rule induction, association, and such things which can be used to uncover worth and value out of data. Right now, second example application that I would sort of give my audience would be in the field of healthcare. As you all know, after COVID, the entire world is shaken up. Before, people used to take their health for granted, but now we realize that our health is not cannot be taken for granted. Now, Google AI came up with a very Google came up with something very interesting. Now, as you all know, diabetic retinopathy is one of the deadliest diseases, and this particular disease sort of causes loss of vision. And it is found out to be the fastest growing reason as to why people become blind. Right? If you have diabetes, soon people suffer from problems of kidney. They also lose their vision. And the curious challenge here is that even the best of the doctors, the most experienced doctors, not that we have too many experienced doctors in this field, but whatever we have few doctors, and even they find it very, very difficult to identify diabetic retinopathy. If you're not able to identify, how will you be able to cure it? This is where I was just listening to a video of Sundar Pichai, wherein he and his team they came up with a machine learning technique. When what they do is basically from the historical data of retinal images obtained from those patients who suffer from diabetic retinopathy, as well as those patients who have clear vision, they took thousands and thousands of images, fed it into the machine. The machine basically was made to learn certain characteristics, pick up certain patterns in the images of the eye, in the images, which uh, which could later be used to sort of classify fresh retinal images as a potential candidate for diabetic retinopathy or not. Now the machine has learned the pattern so well that you're able to easily get around 90% plus accuracy. You're able to, if you feed a fresh image, the machine now is able to sort of classify with approximately 90-95% accuracy whether or not this particular image and this particular person having this characteristic is likely to suffer from diabetic retinopathy. Just hold your breath. This is just one benefit. One benefit. It's unbelievable. And I'm not trying to sell you a story on a weekend here. Uh, it is this machine learning algorithm has become so smart that it is now able to identify not just whether a person is likely to suffer from diabetic retinopathy, it's able to do an additional task. What is that additional task? That additional task is it's also able to predict whether or not a person is likely to suffer from cardiovascular risky events like heart attack and such things. Whether a person is going to get a stroke in advance through eye scan and such things. These anomalies also can be predicted, right? So these are some of the breathtaking examples and benefits of machine learning, data science, and such things. I'll move to the third area, which is BFSI, banking, finance, services, and insurance. Now, one of the benefits of using data science is that you can forecast Bitcoin prices, you can forecast stock prices, and if you feel that a particular stock is expected to do well in the coming month, maybe you might want to buy it. On the other hand, if you feel that a particular stock price is going down, you might want to sell it very, very quickly. And you have specialized models. Particularly, you can employ what is called as RNN, or recurrent neural network, which is very good at identifying sequential data. And it's able to sort of say which of these stock prices are going to go up, or which of these stock prices are going to go down. So it has numerous benefits in the area of forecasting cryptocurrency and such things. The last application that I would like to talk about here is in the field of gaming and entertainment. Now, this is a real life example. In 2018 Wimbledon, IBM Watson used artificial intelligence to basically analyze the player emotions and expressions through hundreds of hours of footage. You can imagine a Wimbledon match, and if there are continuously if it's a match which goes on for 4 hours or 5 hours, it becomes a bit difficult for a person who comes from office who's very, very tired to look at 5 hours of footage. So what IBM Watson did was to sort of distill the most expressive, emotive, emotionally surcharged moments alone by using NLP and such techniques, by using deep learning techniques, and they were able to generate highlights. From a 5 hour footage, they were able to reduce it to half an hour or 45 minutes of the most sensational moments in the tennis match. So these are some of the benefits that you see. I don't even have to talk about smart cars, smartphones, and such things. We have already spoken about that in depth. And at the back end, you see a lot of machine learning techniques and such things in operation. So this is a slide which speaks about the application part of data science. I move on to analysis strategy. This would give you a very, very high level perspective as to how you analyze. Instead of being very, very high level, let's get down to the nuts and bolts and look at a step-by-step procedure as to how you can analyze the data. Is there a strategy? I will just reveal this strategy to you in 5 steps. Now, when somebody gives you a data set, and I've heard a lot of people sort of tell me, so where do I start the data analysis of the data set? How do I start? Is there a tip? Is there an idea that you can sort of give me? And for the benefit of those people, I've just sort of formulated this particular slide. You can just see here. Usually, if the data is in a structured format, I repeat, if the data is in the form of structured, it can be stored in your RDBMS, Relational Database Management System. So you can use SQL, our good old SQL. SQL is not something which is new. It has been in the market for around 20, 25 years, or perhaps even more than that. What happens in a real time scenario is that nobody gives you data on a platter. Data is stored in different tables. One piece of the data, let's say demographic details, is in one table, and your service usage pattern in the another table. Account related information is in the third table. Product details may be in the fourth table. Question is, when you have fields scattered all over, how do you sort of bring it into one common platform? This is where SQL helps us perform very, very complex joins. SQL is very, very easy to use, and the commands are also very, very useful and user friendly. So you can use SQL to perform these complex joins, and you can aggregate the data. You can pull out demographic details. You can assemble it with the account related information. You can also collate other useful information, and you can sort of join the data. So that is how you can sort of come up with the base data. This is the first step. Now I move on to the second stage. Use the slide indicatively, because once you have the data in SQL, now SQL might not support extensive analysis. I've read a few blogs which say that you can do a lot of analysis and such things, but usually what happens is that once you have the data in SQL, this is the data which we call as base data. What we do is we pull this data into Excel environment. Now, the good old Excel is very, very useful because it helps us sort of summarize the data, perform a few charts and such things. It also helps us, if you want to do a quick frequency chart, or a few, you can do a pivot table or a bar chart or a pie chart. Excel has one of the best sort of graphs and such things. So it helps you do elementary analysis. To some extent, you can also do hypothesis testing and such things. So this is the second stage of data analysis. I take the data, and I sort of use Excel to sort of analyze the data. What is the third stage of analysis? I move on to Tableau. Why Tableau? Because Tableau is absolutely powerful. It is considered to be a king as far as BI is concerned, business intelligence. You can create very, very exciting dashboards. You can sort of deploy it into your manager. You can sort of make it you can sort of put it in a production environment as well, and you can at the end of month pull out very, very interesting reports so that your manager can quickly see from his dashboard what is happening with the state of business, which are the products which are doing well, which are the products which are not doing well. All these high level insights can be drawn from Tableau. This is the third element. This is the third tool that you would need, particularly if you are into business insights, if you want to do a lot of complex joins and such things. Not joints, you can do elementary joints and such things. Tableau supports a lot of joints and such things, but it's primarily seen as a tool for visualization and such things. So this is the third step. Now let me just make a move on to the fourth step. Tableau is not a tool which is designed for modeling. Now, what is a model? Model is nothing but a mathematical equation. Now, if you want to do any modeling and such things, we tend to use R. R is a very, very powerful tool, and R is a tool which is designed to do a lot of statistical analysis and such things. So it has a lot of powerful packages. The last time I checked, R has around 12,000 different packages which can be used for data analysis and such things. It is tailor made for statistical analysis. So this is the fourth stage that we push the data into. The fifth stage would be Python, right? Now, in today's day and age, Python is widely used along with R. Now, R and Python were on the same footing, but Python has stolen a march over R, simply because Python has high-level APIs like Keras, TensorFlow, and Theano, and Python facilitates deep learning through these high-level APIs. So, not that R does not have Keras and TensorFlow. It does have Keras and TensorFlow, but Python is the one which has a lot of community support. Since Python has been around for some time, Python has richer community support as compared to R. And even if you get into a few challenges and such things, you can sort of resolve it, because you have a lot of help, strong, solid help in Python. So Python is preferred. Python has around 118,000 plus packages. Not all of them are used for data analysis and such things. Python packages are mainly used for deployment. There's also a framework called as Django, which is used for designing, which is used for web framework, which is used for creating a web framework, designing your websites and such things. So this is the sequence of steps normally that we follow in the industry while we analyze the data. To just summarize it, we uh, use SQL to do joins. We use Excel for graphs and tables and for summarizing the results. We use Tableau for high-level dashboards and such things. We use R for statistical model building. And finally, we use Python for deep learning, keras, and such things. With this, we come to the end of today's presentation. I thank you profoundly for sticking with me. I request you to subscribe to my channel, The Outlier. In future, we are going to make a lot of videos which will demystify a lot of these concepts. Which concept, which technology, which tool that you need to use, that is something which we are going to speak in depth. I request you to again subscribe to my channel and click on the like button. To just summarize what we have seen the different types of data. We have seen what is data science, what is the strategy that we employ to analyze the data. We have also seen the different technologies. We've seen differences. We have seen high level. We've seen different kinds of data in terms of telecommunication data, retail data, and government sector data. I thank you so much for your support. I thank you so much for your time. Have a good day.